Hi there, ladies and gentlemen. It's Mr. Pouts, and we're going to do section 5.1, starting off chapter 5, all about linear equations. And we're going to focus today on slope, because slope is a big part of linear equations, since all lines have some sort of a slope. So our goal, and maybe you notice why I have the picture in the background that I have it, but our goal is to find rates of change, which in other words is slope, from tables, graphs, and the slope formula. So we're going to talk about 3 different ways. All right? So let's get some vocab here. So first of all, rate of change. When we say rate of change, that's just dealing with the same thing as slope, but it's dealing with word problems. So rate of change is the relationship between two changing quantities. All right? And in other words, the rate of change is the change in the dependent variable over the change in the independent variable. And that's when you're dealing with any type of situation. In other words, that would be the change in the y, because the dependent variable is the y, over the change in the x. And the way I remember it's y over x, I mean, it's opposite than what we normally think of with graphing. But when you go turn the light on, you have to stand up first. If you're sitting in a chair, you stand up first. The change in the y, that would be the up and down axis. And then you walk to the light. And that would be the left and right axis. So I've been writing it like this with the delta symbol, because that also represents change in y over change in x. All right, slope, more specifically, is the ratio of vertical change to horizontal change. So that's rise over run between 2 points of a line. So this is where we have it right here, rise over run. Remember, slope is rise over run, rise over run, rise over run, rise over run. Just repeat that to yourself 15 times before bed every night, and you'll understand slope. Now, just keep in mind, these two things, rate of change and slope, they're essentially the same thing. There's two different words for the same thing. If you think about it, the rise would be the change in the y's of an x-axis, or of a coordinate plane, of a line on a coordinate plane, and the run would be the change in the x's. All right, 4 different types of slope real quick here. When you're dealing with giving slope a number, again, slope is just a number given to, it's just a measurement for the steepness of a line. Okay? So how steep a line, if it's going up from left to right, that would be a positive slope. If it's going down from left to right, that's a negative slope. So again, we have our little snowman there, or penguin on the snowshoes. And if it's just going straight left to right, there's no slope to it, so it's a 0 slope. It's like you're doing cross-country skiing. You actually have to push yourself. If it's going up and down, that's not possible. You'd just be falling, so that is undefined. And maybe you can make that connection, undefined, between the vertical line test, and since a vertical line would not pass the vertical line test, it's not a function. So anything time it's not a function, it's undefined there. All right, so you can find the rate of change, or slope, of a relationship from a table, a graph, or using the slope formula. We're going to do those 3 types today. These 3 types are really easy. It's just the more practice, the better you become at it. So let's say the rate of change from tables, first of all. All right, so remember, rate of change would be the change in y over change in x. So the change in the y over the change in the x. So the change in the y, we always have the x's on the left, the y's on the right. We'll do this for both examples. And this will actually tell us if it is a line or not. If there's a consistent rate of change, it is linear. Oh, whoa, 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 whoa. There's a consistent rate of change. So let's find the change in the y. So to find the change in the y's, we just do this opposite. We do 520 minus 260. Might need a calculator to do this faster, but oops, 0, 1, 3. So 310. That means it's going up by 310 right there. How about here? 310. Wait a minute. I wrote that wrong. 520. Ah. All right. Made a mistake. Got an eraser. I'm gonna fix it. Alright, so 520 minus 260. Oh, it's going to be 260. Alright, so it's actually up 260 as this goes up 1. Let's check the next one. This is going up 260. And this one is going up 260 as well. They're all going up by 260 as these all go up by 1. Oh my goodness, I am sorry. This thing is freaking out on me. Alright, this is going up by 1 plus 1. So the constant change in x over change in y, or sorry, change in y over change in x, don't mix that up. It's opposite here. Would be 260 over 1. In other words, the slope is 260 over 1. Alright, let's look at this next one. So this would also be linear because it has a constant slope. Let's look at this next one. The change here would be plus 6, plus 6, plus 3, and plus 6. This is plus 1, plus 1, plus 1. So you might remember from last chapter that this would not be linear. Because if you look at here, the change in x over change in y would be 6 over 1. Sorry, change in y over change in x. I'm really messing that up. Would be 6 over 1, whereas this one right here would be 3 over 1. Not consistent, so it's not linear. Let's use that change in y over change in x to figure out if these two are linear or not. So why don't you pause it and do each of these two on your own, linear or not. Alrighty, so I labeled all the changes in the x's and the y's for both of these. And if we look over to the one on the left, every time the x goes up by 5, the y goes up by 40, or the number goes up by 5, the money goes up by 40. So the constant change in x over change in y, and this would be, sorry, change in y over change in x would be 40 over 5, which reduces to, if you want to reduce it, would be 40 divided by 5 is 8, or 8 over 1. Okay? I always leave slope as a fraction because that shows the rise over the run, or the change in the y over the change in the x. Okay, but if you look at the second one, and this would be linear then, since it's always the same. If you look at the second one, though, we can look at the change in y over change in x here, and it'd be 3 over 1. But if you look at it here, it'd be 2 over 1. So it's staying constant, going up by 1 on the x side, or the years, but the inches, or the y side, is not always the same. So that means it's not linear. It's not consistent, so it's not linear. Alright, so that is finding slope, or finding the rate of change from a table. Remember, rate of change is the same as slope. Talking the same thing here. My thing would work. Alright. So we're going to now find the slope of a graph. Now if you look at a graph, and here's an example here. Well, I have two examples. Well, let's cover this one up. Let's just do this one first. First, pick 2 points on a line. So 2 points that you know are on the line. And these are 2 points that are picked for you already. This one you can tell is on an intersection. This one is on an intersection. I wouldn't pick this one right here because I don't know what that is. It kind of looks like it'd be 2.5 and 1, but we don't want to deal with halves. We don't want to deal with anything of fractions. So we're going to deal with whole number coordinate points. You can also check one up here. It doesn't matter. Any 2 points on a graph would work as long as you can tell they're a point on the graph. So that would be pick 2 points. Check. Count how far up or down, so the rise, in this case we're going up, and right, the run, it takes from the left point to the right point. So if we go from left to right, we're going up 2 units, and we're going right 3 units. So those are both positives if you're going up and right. So the rise of a run would be, the up would be 2, the run would be 3, and that would be your slope. Rise or run. I'm going to take these as well. Let's see this one. 1, 2, 1, 2, 3. So it's up 2, over 3. So that would still be 2 over 3. Okay? Let's say I wanted to take this one big, I'll write this in blue, from this point all the way over to this point. Let's check that one. I know it's different. The rise is 1, 2, 3, 4. Over 1, 2, 3, 4, 5, 6. But then 4 over 6 reduces to 2 over 3, which is the same thing that we had here. So the slope is always, does not matter what points you pick, as long as there are 2 points that you can tell are on that line, you'll have the same slope, and it's the rise over run. So the slope for this one is 2/3. Okay? Look at this one. Rise over run again. Rise over run. From the left point to the right point. Looks like we picked this one right here. That's a good one to pick. This one right here. It's hard to tell. I don't know if I see any other ones that would actually be exactly on an intersection. So we're going to go from left to the right. We go down 4 units. So that would be, the rise would be -4 because you're going down. And right 5 units, so that'd be +5. So your slope would be -4 over 5 because that can't be reduced. All right? So down 4 over 5. -4 over 5. Rise over run. Rise over run. Okay? So the fraction is rise over run. Why don't you try that? I have 2 here for you. Just try A and B on your own. Try to find the rise and the run. And there's actually 2 points given to you on each of those as well to use for your slope. All right, try those on your own now. All right, so I did the first one for you. I went up 2 and over 5 to get there. So the rise is 2, the run is 5, so that's your slope. And then for B, looks like the slope, it looks like we're going down to get from right to left. So down 2, -2, and over 1, 2, 3, 4, 5, 6. So -6. So the slope would be negative, or sorry, not 6, plus 6. So it's +6, you're going to the right. -2 over +6, which reduces to -1/3. So the slope of that one is -1/3. All right. You could also pick 2 other points, like right here. You could say this is a point. And I'm going to go from here to here, you go down 1 and over 3. That's where you get the -1/3 again. Same thing, -1/3. Just picking 2 different points. All right, we're going to do our last method, which is the slope formula. And this is one that'll always work for you. Sometimes it's the hardest for students to remember, but it will always work. So let's just read this. It says you can use any 2 points on a line to find its slope. Now, obviously, if you can look at the graph, you just do the rise over the run, and that's probably the easiest way. But you might not have the graph there. So use subscripts to distinguish between 2 points. In the diagram, x1, y1 are the coordinates of point A, and x2, y2 are the coordinates of point B. To find the slope of line AB, you can use the slope formula. Here's the slope formula for you. The slope formula is rise over run, we know that, but it's y2 minus y1 over x2 minus x1. So in other words, and the denominator cannot be 0, so that's what it's saying there. And I think an example will be the best for you here. And if you're given 2 points, you pick which one is your x2 and your y2, and your x1 and your y1. So we know that this is going to be an x and this is going to be y, so we'll say this is our first point. This is x1 and this is y1. That's our first point. Our second point will be x2, our second x, and our y2, which is our second y. So then I'm going to plug it into our formula here. The slope formula is y2 minus y1 over x2 minus x1. And I'm going to plug those numbers in. So our y2 is our second y is -2 minus our first y, which is 0, all over our second x, which is 3, minus our second y, which is -1, so minus -1. Okay, couple of notes here. Make sure when you have minus and negative, it just becomes plus positive. So that would be negative 2 minus 0 is just negative 2. 3 plus positive 1 now is 4, which reduces to negative 1 half. So there's the slope of that line, just using the slope formula, as long as you have the x2, y1, or x1, y1, and the x2, y2 labeled. All right, why don't you try this one on your own right here? All right, so I labeled the x2 and the y, or the x1, y1, x2, y2. So I'm going to plug in for my formula here. Y2 minus y1, so that's negative 1 minus 3. And x2 minus x1 would be 4 minus 1. If I reduce that, I get negative 4 on top and positive 3 on the bottom, and that can't be reduced at all. So there we go. We have negative 4 thirds is our slope. All right, one quick note before we go. This is just interesting this is a zero slope we said at the beginning if it's going left to right. And that's because if you pick 2 points, it'll end up getting you a 0. And for a vertical line, if you do a vertical slope, you'll end up having a 0 on the bottom of your fraction, which is undefined because you can't divide anything by 0. So that was just an interesting note for you when you are finding slopes of vertical and horizontal line. That's horizontal are 0 slopes and vertical are undefined. So I just want to leave you with this. Explain the 3 different ways to find the rate of change or the slope. Have a good rest of your day.